This video introduces nonparametric fitting using Statistics Toolbox and Curve Fitting Toolbox. Let's assume that you need to model a relationship between two variables, x and y. The true relationship is described by this blue curve. Unfortunately, you don't always know what this curve looks like. The only thing that you have to work with is some noisy samples drawn from the original curve. In this contrived example, the blue curve was generated using a second-order Fourier series. The title bar of the figure contains the equation. If you knew this information in advance, you could choose an appropriate equation for a nonlinear regression. This technique is often referred to as parametric fitting because you assume a specific parametric relationship between your variables. Let's assume that you didn't know this data was generated using a Fourier series. The only information that you have available is the set of data points. This is a nonparametric fitting problem. Here you need to generate a fit without assuming any kind of parametric relationship between the variables. Smoothing techniques, like localized regression, are one example of nonparametric fitting. Localized regression involves fitting a large number of curves to local subsets of the data and then combining these into a single larger curve. The accuracy of the localized regression model depends on choosing an appropriate value for the smoothing parameter. If you choose a smoothing parameter that is too large, you'll underfit the data. Here I'm deliberately choosing a very large smoothing parameter, and as you can see, the fitted curve is much too flat. It doesn't describe the true relationship between the x and y variables. Alternatively, if the span is too small, your model will overfit the data. Here, the fitted curve is much too responsive. The predictive model is capturing both the trend and the noise. You can identify the best spanning parameter for this dataset using a technique known as cross-validation. This plot shows a localized regression model generated using an optimal span that we estimated using cross-validation. This next plot allows you to visually compare the relative accuracy of the two models in estimating the true relationship between x and y. As you can see, the nonparametric fit is almost as accurate as the nonlinear regression model. Equally important, the nonparametric fit can be estimated without the need to specify the right parametric model for the regression analysis. In many cases, you aren't just interested in estimating the relationship between x and y. You also want to generate confidence intervals to show how certain you are about the location of the curve. Here, a related technique called bootstrap is used to approximate confidence intervals for the nonparametric fit. This example was developed using a specific nonparametric fitting technique called localized regression, or LOIS. These same methods can be applied to other nonparametric techniques, such as smoothing splines and interpolants. You can find a complete description of Curve Fitting Toolbox's nonparametric fitting algorithms inside the product documentation. For more information about cross-validation or bootstrap, please consult the Statistics Toolbox documentation set. Thank you.